Assalamualaikum warahmatullahi wabarakatuh, and hi guys. So for today we're gonna learn about how to solve inverse of how to solve linear equation, linear system by using inverse of matrix, or sometimes they also call as a cofactor method. Why? Because we will use um, cofactor method to find the inverse of matrix A. Okay, and then to find the unknown variable, which is x, y, and z. Okay, so before we start with this one, so let's take a look with uh, some intro about the inverse of matrix. Okay, let's say if they give to you or consider a linear system of matrix a linear system in the form of, I just write down in the form of ax equal to b, in which matrix A is equal to A11, A1, A21, A31, A12, A22, A32, A13, A23, A33. And we have matrix X. Let's say our unknown variable is in the form of X1, X2, and X3. And then we have matrix B is equal to B1, B2, and B3. So right now, we want to find this one, the unknown variable, which is our x. So how? Okay. Remember that ax is equal to b. So to find this, okay, we need to bring the matrix of A at the right side, right? But since right now this is in the form of matrix, you cannot simply just bring it to the right side and then put -1, something like that, or negative A like that. No, that one is wrong. So, okay, if you remember, inverse of matrix A times with matrix A or multiply with matrix A, you will get identity matrix. And as we know, identity matrix, you multiply with other matrix, it's still, let's say, identity matrix multiply with x, matrix x, so it will give to you matrix x. It does not affect the matrix x. Okay, so in this case, since right now we want to cancel the matrix A and bring it to the right side, so what if we multiply this with inverse of matrix A? Same with the right side. Okay, inverse of matrix A multiply with A, so you get identity. So it will be here identity matrix times x, this one inverse of matrix A times with matrix B. So as we know, identity matrix multiply with any matrix, so it will give to you the matrix that you multiply. Does not affect the matrix. Okay, so give to you matrix x equal to inverse of matrix A multiply with matrix B. So from here, we can find the value of the unknown variable or the matrix x by multiplication between inverse of matrix A multiply with matrix B. Okay. So for this one, to find the inverse of matrix A, we will use, since right now we want to use inverse of matrix, so we use method of this one, 1 over determinant of A, so we adjoin matrix A. Okay, which is, we say that by using the cofactor method. Okay, so before we can proceed with this one, remember, how did you get adjoint of matrix A? How do you get this one? First, adjoint of matrix A is equal to transpose of cofactor of matrix A. So before you can find the transpose of the cofactor, first you need to find the cofactor first. So in other words, Okay, they give to you a matrix A. And then you need to find minor for matrix A. And then you need to find the cofactor of matrix A. And after you find the cofactor of matrix A, then you transpose of the cofactor of matrix A, you give to you adjoint of matrix A. And then you can find the inverse of matrix A, which is by using this formula. 1 over determinant of A multiplied with adjoint of matrix A. Then, after that, you will multiply with matrix B to get the value of X. Okay. So, okay. So, let's take a look on the example first, on how we're going to solve by using the inverse of matrix. Okay. Okay, let's take a look on the example. Solve a linear system by using inverse matrix method. Okay, if we get this kind of question, first we change it into a matrix A x equal to B. Okay, as we know, matrix A is equal to, okay, just write down, matrix A is equal to 1, 1, 1, 2, negative 1, 1, negative 1, 3, negative 1. Remember, from here, okay, and then the matrix X, this is matrix A. Okay, matrix X, since the variable that we have right here is X, Y, and Z. So this is our matrix X, and then the matrix B, which is for our matrix B, is 0, negative 1, negative 8. Okay, this is our matrix B, AX equal to B. So right now, to find the unknown variable or this value, so first we need to find the inverse of matrix A. So for our first step, if we want to find the inverse of matrix A, as we know, first we need to find minor. Okay, minor. So minor for this matrix A is equal to, okay, 1, 1. Remember, okay, M11, M11, M12, M13, M21, M31, M22, M23, M32, M33. So M11 will be 1, 1. So negative 1, 1, 3, negative 1. M12, 1, 2. This one, you can see it. Okay. So it will be 2, oh sorry, 2, 1, negative 1, negative 1. M13, 2, negative 1, negative 1, 3. M21, so it will be 1, 1, 3, negative 1. M22, 1, 1, negative 1, negative 1. M23, negative 1, 1, negative 1, 3. M3, 1, 1, 1, negative 1, 1. M3, 2, 1, 2, 1, 1. M3, 3, 1, 1, 2, negative 1. Then solve all of these. Okay, to get the answer for minor. Okay, solve one by one. For M11, M11, negative 1 multiply with negative 1, 1 minus with 3, so negative 2. So negative 2. Then M12, this one is for M11, m1, 2. 2 times with negative 1, negative 2, minus with negative 1. So, negative 1. 2 times 3, 6 minus 1, so 5. 1, 3. Okay, and then to find for 2, m2, 1. Negative 1 minus 3, negative 4. Then m2, 2, negative 1 minus negative 1 is 0. And then m2, 3, 3 minus negative 1 equal to 4. m3, 3. Okay, I just write down because you can see it clearly. Let's say if you get the answer wrong, so at least you can check it, okay? 1 times with 1, 1, minus negative 1, so 2, m3, 2, 1 minus 2, negative 1, m3, 3, negative 1 minus with 2, so you get negative 3. So 2, negative 1, negative 3. So this is our final. Okay. Then after that we need to find the cofactor. So 2, cofactor of matrix A. Okay, to find the cofactor of matrix A, you can use the formula plus minus plus minus plus minus, or you also can use this one, negative 1 I plus j. Remember the formula for cofactor? Negative 1 I plus j minus ij. Okay, mij. Oh, what is this? mij. Okay, so mij. So for this one, okay, right now we want to find for 1, 1, so 1 plus 1. Our minor for this one, it will be negative 2. Okay, and then we have negative 1, 1 plus 2, negative 1, negative 1, 1 plus 3 times with 5, negative 1, 2 plus 1 times with 4, negative 1, 2 plus 2 times with 0, negative 1, 2 plus 3 times with 4, negative 1, 3 plus 1 times with 2, negative 1, 3 plus 2 times with negative 1, negative 1, 3 plus 3 times with negative 3. Okay, this is our cofactor. We need to solve it to get the answer. Okay, or you can see it from here. Sometimes there is the formula negative 1 power to the power of 2, you get positive, negative 1 to the power of 3, negative, negative 1 to the power of 4, positive. Same with this one, negative 1 to the power of 3 is negative. This one will be positive, negative, positive, negative, positive. So that's why sometimes you can see some of them, some of people use plus minus, plus minus, plus minus, substitute this symbol inside the minor to find the cofactor. Okay. So from here, positive negative 2, it will be negative 2. Negative to negative 1 will be plus 1. Positive 5, it will be 5. Negative to negative 4, it will be positive 4. Plus with 0, 0. Negative 4, positive times with 2, positive 2. Negative to negative of 1, it will be 1. Positive negative 3 is negative 3. So this is our cofactor. Okay. Then the next one, you already got the cofactor, and before we can use find the inverse of A, we need to find adjoint of A. What is the adjoint of A? Adjoint of A is a transpose of cofactor. So transpose of this cofactor, negative 2. Okay, I write down first the cofactor. Okay, so transpose of this matrix, you get negative 2, 1, 5, 4, 0, negative 4, 2, 1, negative 3. So this is the adjoint. Okay, remember transpose, row will become column. First row will be the first column. Second row will be second column. And third row will be the third column. Transpose. Okay, after you get this one, then we can find the inverse of matrix A. Oh, if you take a look at the inverse of matrix A, you need to find 1 over the determinant of A. And you can see from here, we didn't find determinant of A yet, right? So, how about if we find the determinant of A first, before we find the inverse of A? So, determinant of A is equal to, remember, for determinant, you can use third order determinant, or you also can use higher order. And as for me, I want to use higher order, in which I see that from here, even though matrix A doesn't have 0 inside the matrix A, but okay, there is no 0 inside here, but we have 0 in the cofactor, right? You can see it from here at column 2 or row 2. We have 0. But for now, I will choose column 2. So, I will expand along second column. When you expand along the second column, it will be A12, C12. Remember, second column here, second column, plus with A22, C22, plus with A32, C32. Okay, for higher order, if you choose second column, it means that for column 2, second column, this one is constant. The one that change is the row. If you can see a row, 1, 1, 2, 2, 3, 3. Okay, so just substitute the value of element of A and cofactor of A and cofactor of A for column 2. So element of A for, remember this one, 1, negative 1, 3, 1, negative 1, 3. 1, negative 1, 3. Okay. As our cofactor, it will be from here. You can see it here. This is before we transpose. So we can use this one. So 1 times with 1, 0, 1. So 1 minus plus with 0 plus with 3. So it will be 4. So this is the value of our determinant. Okay, next one. We already got determinant, so we just need to find the inverse of A. Inverse of A is equal to 1 over determinant multiply with the adjoint of A. So in our case right now, 1 over 4, adjoint of A, negative 2, 1, 5, 4, 0, negative 4, 2, 1, negative 3. So it will be negative 1 over 2, 1 over 4, 5 over, okay, sorry, 4 over 5, 1, 0, negative 1, 2 over 4 is 1 over 2, and then we have 1 over 4, negative 3 over 4. Remember, this is inverse of A. But since right now we want to find the x value, So it will be 6 step, the last step for this one, find x is equal to inverse of A multiplied with matrix B. So inverse of A is negative 1 over 2, 1 over 4, 5 over 4, 1, 0, negative 1, 1 over 2, 1 over 4, negative 3 over 4, multiply with our matrix B, which is equal to our matrix B. Where is our matrix B? 0, negative 1, negative 8. 0, negative 1, negative 8. So we try to solve this one. Multiplication of matrices. So row multiply with column. 0, negative 1 over 2 multiply with 0 plus with 1 multiply with negative 1 plus with 1 over 2 multiply with negative 8. Okay, and then 1 over 4 multiply with 0 plus with 0 multiply with negative 1 plus with 1 over 4 multiply with negative 8. And then we have 5 over 4 multiply with 0 plus with negative 1 multiply with negative 1 plus with negative 3 over 4 plus multiply with negative 8. Okay, then solve this one, you will get okay, negative 1 over 2 times 0, 0, negative 1, this one will be negative 4, and then 0, 0, negative 2, and then 0 plus 1, and then 24 over 4, we get 6, 6. So we have negative 5, negative 2, and 7. So this is our value of x, y, and z. So our x will be equal to negative 5, y will be equal to negative 2, z will be equal to 7. Okay, let's say if you want to make sure that your answer is correct, you can try to check it by substitute this value inside the linear system equation, this one. Okay. Remember, our x is equal to negative 5, our y is equal to negative 2, our z is equal to 7. So, just substitute inside this equation and check if your answer is consistent with this one or not. So, the first equation, x is equal to negative 5 plus with y, which is negative 2, plus with z, which is 7. Negative 5 minus with 2 plus with 7, yes, it will be 0. Okay, so this one is correct. And then the second one, we want to check on this one. 2, negative 5 minus negative 2 plus 7. 2 times with negative 5, negative 10, plus with 2, negative 10, plus 2, you get 8. Okay, negative 8 plus 7, you get negative 1. So, it's correct. Want to check it. Then we want to check on the third equation. Usually, if the first one is correct, then the other will be correct too. Okay, negative, negative 5 plus with 3, negative 2, minus 7. Positive 5 minus 6 minus 7, you get negative 8. So this is correct. So your answer is correct. So that's all for inverse of matrix. Thank you.